Paul Hewitt, the book's author, and his friend Burl Gray wondered one day what would happen to the tension in a rope suspended on either end of a wooden plank, like the kind used to suspend sign painters. It seemed reasonable enough that if you stood in the center, the tension in each rope would be the same. But what would be the tension in each rope if the painter walked closer to one rope or the other? Would the tension in the rope near the painter be greater and the tension in the other, more distant rope be less? More importantly, was the amount the tension increases in one rope the same as the amount the tension decreases in the other? How did the rope know how much to change? The lab materials consist of a meter stick between two digital balances and a 500-gram mass to be placed in the middle and along the meter stick. As you can see, the balance on one side reads 0, and the meter stick is ranged from 0 to 100, and the balance on the other side reads 0. The 500-gram mass will now be placed on the meter stick at the 50 centimeter point. As Hewitt suspected, the 500-gram mass is evenly distributed on both sides of the balance. At this point, we are going to take data. Now, we're placing the mass on the one end of the digital balance at 0, and we're looking at the data for both 0 and 100. Now we're going to move the mass to 10 centimeters and look at the digital data. Now we're going to move it to 20 centimeters and look at the digital data. Now we're going to move the mass to 30 centimeters and observe the digital data. Next, we're going to go to 40 centimeters and observe the digital data. And lastly, we'll return it to 50 again to verify what we had before, which is approximately equal weight on both. Okay, now we have the results for 0 to 50 centimeters and how the masses on each balance change. What we want to do now is we want to predict what the rest of the data will look like from 60 out to 100 centimeters and how the weights will change. Once we've done that, we can test the hypotheses and see if it's correct. And looking at the data, we can write a generalization that explains these results. Good luck.